All right, good morning. Today we'll be talking about effective instruction in math. I'll be doing this. I'll be connecting a few texts that we've read throughout the semester when doing this. And all right, so the first thing we're going to talk about is instruction in math. I got a lot of these ideas from Jim Burke's book, Effective Instruction. The first thing we can do is varying our instructional methods, so not using the same cut and dry tactics every day. First off, this will get boring for the students and yourself. And second off, it's going to make the material more accessible to all students. So if you use few different methods to introduce the content to the students, more of them are going to be able to soak it up. Another way is teaching our students explicitly how to think, learn, and remember. So a lot of times this can come in the shape and form of teaching them how to properly write notes, how to attack problems, things of that sort that we sometimes take for granted, but if we make these explicit, a lot of the students may have not learned how to properly take notes or properly look at word problems, things of that nature. The other one is assessing, understanding, and using results to improve teaching. So this would come in the form of formative and summative assessments. So assessing understanding during the class could be simple things like fist of 5, thumbs up, thumbs down, stuff of that nature. And you can just read faces. There's a lot of times it would be up there and you'd be like, well, either the kids completely understand this or no one knows what I'm talking about and I have to go over this again. So that's the in-class adjustments that you can make. After class adjustments, you can use results to improve your teaching. So if I gave students a exit slip or a worksheet they had to do or some type of project, using those and assessing the understanding on that, so the next day I can rework my lesson, make some adjustments to it to fill in those potholes that the students may have had throughout the day, and using the right tools and technology to enhance the lesson. So this could come in the form of Desmos in math. So I like how it says to enhance the lesson, because we're not just throwing out technology, gimmicky technology, because our principal said so. So Desmos is a math, it's a math website that has tons of activities on it that are very interactive for students and can really help them develop that conceptual understanding and procedural fluency. All right, so with instructional sequencing, I took a lot of these ideas from Tomlinson McTighe. The first one was organizing instruction around big ideas and essential questions. So this is about making, when we're introducing topics, so having a big idea or essential question that we can connect their assignments back to, so the students always know the goal that we're going on. Students need a balance of student construction of meaning and teacher guidance. So it's not just all direct instruction on my part, or it's not all just discovery on their part. They need a little bit of both. In math, it seems to work the best with the I do, we do, you do, where there's a little bit of focused instruction. I introduce a concept to the students. We all go through a couple problems together. The form of that may change day to day. The problems, how we go through them together. Sometimes maybe they work with a group. Sometimes it might be guided questions. Sometimes it might be in the form of partner work. And then the last part is the you do, where students have the opportunity to do independent practice. So really sit down by themselves and think out their thoughts and really tackle the problems completely alone. We have to make students make connections through the use of graphic organizer, questions, study guides, flowcharts. So connecting our materials on that is very foundational. So referring back to old concepts that we may have done, asking students, okay, where have we seen this before? What properties would we use here that we've learned before? Things of that nature. And then we use connections to improve the comprehension and memory. So connecting what we've learned with, say, if I was teaching percents, how that deals with interest, and just connecting those two so that long-term memory stays for them. Right, so using academic language, I took a lot of these from Swears and Crawford. The features of an academic conversation. So it requires both partners to talk. So creating a task that makes both partners communicate, requires critical and creative thinking, takes advantage of controversies and conflicts, recognize and reduce ambiguity, encourages thinking based on principles, laws, and approaches of the discipline, build in opportunities for transfer of knowledge and skills, and provide choice of ownership. In math, what effective conversation or using academic language could look like is what we've done in my class. We have, what are they called? They're called conversation guidelines or AB talks, where we've gone over explicitly about how you would how you could structure a math talk. And we practice this for a few days. There are also like conversation frames that teach students how to properly engage in an academic conversation. We've done some activities, like there's a great Desmos activity that requires students to use academic language, where they have to guess like the coordinates on a coordinate plane of another student and the other student. So one student would graph a point on the coordinate plane, and the other student would be connected to them through the computer, and they can't obviously see what the point was. So they have to try to figure out in the least amount of terms, the least amount of questions possible, what their point is. And there's so many possible points that students found the need to use academic language to most effectively get there. They would be asking the students, is it in quadrant 1, 2, 3, 4? There's a positive or negative intervals, stuff like that, before they didn't really see the need to, because they could just be like, oh, it's in the top right. But then that would leave students being like, well, what's the top right? How far right? So creating activities such like that creates the need for academic language. It makes their life easier by using academic language. Will help them really develop those skills. Differentiated instruction and scaffolding. So this becomes, this is Retta Hammond, how the first book we read of the course was Culture Relevant Teaching in the Brain. So culture relevant pedagogy and lessons makes the content a lot more relatable, a lot more to grasp for all students. Students should all participate in higher order thinking. So this means that we shouldn't have our lower students just memorizing and just like doing rote memorization. So just memorizing and crunching numbers and stuff like that. All students should be participating in the same difficulty. So all students should participate in higher order thinking. All right, allowing time for group work and effective conversation. This goes back to Vygotsky's social development theory, where he said that the most meaningful learning takes place in community setting. And this also increases the zone of proximal development, which he talked about as well. Preferential seating. So this would be differentiation for our needed students who need a little more guidance. This could be students with IEPs, students with 504s, whatever it is. Giving them preferential seating close to the board, close to the teacher's desk could help them out a lot. Prioritize check-ins with specific students. So this is very relevant in math. Like if students are working on the independent practice, I know the students that I need to check in with first and give them a couple extra, maybe a few extra points, maybe guide them a little more, stuff that they may have not picked up on that most of the class did. So I'll check in with those students first, and also providing multiple entry points. So this could come in the form of having visual representations as well as algebraic notation. Because I've found a lot of my students, especially the students with IEPs or my struggling students, they're the ones that need that do a lot better with visual representation. So showing both these examples has helped them out a lot. Then the EdTPA central focus for math is to develop conceptual understanding, procedural fluency, and mathematical reasoning and or problem solving skills. So when when creating lessons for a class, these are all things that we should reflect on. Of if my lesson is creating conceptual understanding, is my lesson having students practice procedural fluency, are they engaging in mathematical reasoning or problem solving skills? So these are all things that not just for the EdTPA I should focus on, but I should reflect on every single day with my lesson plan, because they're the most important for kids to develop the full understanding of the math. Thanks.